Hi guys, today we are looking at the valid anagram. This is part of the roadmap to learn LeetCode on LeetCode.io. As you can see, we have the roadmap here and arrays and hashing, and here we have the valid anagram problem. So what is the problem? The same problem can be found on LeetCode.com. As you can see, problem 242. So what is the problem? Given two strings s and t, return true if two strings are anagrams of each other, otherwise return false. What is an anagram? An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. So what does this mean in simple words? Let's take a look at the example here. We have race car and car race. As you can see, both strings have the same amount of characters and the same characters if you take a closer look. The only difference is in the order of the characters. So in this particular case, we have an anagram because, as stated here, one string is an anagram of the other string if it has the same amount of characters and it has the same characters, whereas the order of the characters is not relevant. So as you can see here, we have to return true in this case. And here in the next example, we can see that we have jar and jam. So the R and M are different. And because of that, we have to return false. The solution of the particular problem should have the time complexity of big O of n plus m, and it should have the space complexity of big O of 1. The first solution that I can think of would be to sort these strings and then compare to each other and check if they are equal or not. So this way we would know if these strings are anagrams of each other. Let's take the car example. We'd have car, and then we have rack. I don't even know if this is a word, but let's assume. So the characters in this word will be arranged as follows: A, C, R, and for the other one, also A, C, R. So these both strings will be equal, and this way we know that this is an anagram. And then we have to return true. Here is the solution in the code. As you can see here, first we have to check if the length is the same of both strings. And if it is not the same, then we return false. Here we can see that we use the sorted function, the Python sorted function, and the sorted function returns an array with the characters sorted alphabetically. After that, we can compare the two arrays to each other. So let's execute this one. We have the main method. As you can see, I will execute this particular file, and true is returned. If we change and add a character here and then execute this, false is returned. If I replace the R with a N, for example, and execute this one again, still a false is returned. And now we have the anagram. As you can see, race car and car race, as we had in the example. And we have to execute this one, true is returned. The complexity of this particular solution, the time complexity, is big O n log n. This is because we are using the sorted function here. And the sorting algorithms in most of the languages use a general purpose algorithm to sort elements, and this algorithm usually has a time complexity of n log n. And that's the reason why in this particular solution we have this particular complexity for the time. And for the space, for this particular solution, we have big O of n complexity. This is because we are creating two additional arrays here, which are the same size as the number of characters in the strings. Because of that, we have the space complexity of big O of n. Definitely, we can come up with a better solution in this particular case. One other solution would be to use the dictionary in Python or a hash map in other languages. The idea is to iterate over the strings and put as a value into the dictionary the number of characters which occur in the particular string. Let's say the letter C appears once in the string. We have the dictionary here. And we put the C here as a key, and the value would be +1. So meaning if it appears once, just 1. If it would appear twice, then we would have to here when we finish looping over the string. So the idea is to iterate over the string, the first string, and every time a character appears, increment the count of this particular character and iterate over the second string and decrement every time a particular character appears. So let's look at an example. So we have the example car and rec. So we iterate over the first string. We take the C and add +1, which is 1. And then we take the A +1 and the R +1. And then we proceed with the R. And then we iterate over the second string. We have then the R again. This time we do -1, then we would have a 0. And then we have the A. We do -1 and we have the 0 again, and the C, and we have the 0 again. After that, we iterate over the values in the dictionary and check whether one of the values or any of the values is not equal to 0. If that's the case, then these particular strings are not anagrams. So this is the basic idea. Let's see how this looks like in the code. We can see we have the function as anagram here. We check again the length as the same as in the previous function. And then we have the dictionary. We create the dictionary. We iterate over the first string, as you can see here, and we take the current value, let's say the C, and increment the count by 1, as you can see here. We access the particular count from the dictionary in this way, because the first time when we try to retrieve the count from the dictionary, we may get an error because the particular entry in the dictionary is not there yet. So because of that, to not get an error, we are using this particular function, the get function, to retrieve the value from the dictionary. And if it is not there, then a default value can be defined. As you can see here, the null is defined. So we iterate over the first function, and then we iterate over the second function. As you can see here, we do the same, but only we decrement the count by 1. And then what we could do is to iterate over the values in the dictionary. As you can see here, we check if the elements from the dictionary, if any of them is not equal to 0. If this is the case, we return false, which means that the strings are not anagrams of each other. Otherwise, we return true. So let's execute this one. We have the same problem here, and we have the main method. So we can see that true is returned. We change this to a different character. We will check. We can see that the false is returned after we change the one character. And if we change the size, execute this one again, still false is returned. And now we can see that true is returned. This particular solution that we have here has a complexity of big O of n plus m. So the reason is because we iterate over the strings, 2 strings that we receive here, and then we iterate over the dictionary, but the dictionary can contain only at max 26 elements. This is because we have only letters from the English alphabet, which are 26. And because of that, we have the time complexity of big O of n plus m. For the space, this is similar. We only iterate over the strings of the characters in the strings. And same as with the time, we have only 26 values at max in the dictionary. And this is a constant value. And because of that, we have space complexity of big O of 1. If you found this video helpful, make sure to like and subscribe. I will be posting more LeetCode problems and solutions right here on this channel.